a history of battery and their diverse applications. So in this webinar, we are going to deep dive into batteries history. Chemical to electrical, we will be understanding its fundamentals. We will be see how the inner workings of battery is been done, how does the battery work from its internal components and all its chemical uh, chemical properties also. And we are going to see the types of battery. So this is the brief history of battery. So as we can see, from 1600 to 750 AD, the beginning of battery was came into the reality. The concept of electricity and the battery has been known to the world from the 1600s to 1715 AD. After that, some scientists practically invented battery. Just we can see the galvanized cell. After that, in 1836 to 1885 AD, the Daniel cell battery with its practical application. So as we can see here, in 1836 to 1885, the practical application of battery took place. Like scientists have discovered some batteries which can be practically implemented in in any kind of small toys, or to uh, to lamp a bulb, or to drive the motor, or all these things. Later on, in 1856 to 1886 AD, we got the modern batteries. We have started our journey towards the modern batteries like rechargeable cells and dry cells. At this position, we were quite implementing the batteries inside the different applications. After that, in 1899 to 1980 AD, the modern batteries like alkaline batteries, NIMH batteries was invented. This battery we were mostly using in camcorders, recorders, cameras, mobile phones, again the walkie-talkies, our wall watches. These kinds of application were there of the modern batteries in the remotes, in the toys. And after that, from 1980 to 2022, this was the age of the lithium ion batteries. Here the lithium ion batteries are there at peak till now, right? So in everything, like even in our mobile phones, in laptop batteries, in the UPS, in electric vehicles, we are using lithium ion batteries. So there are different types of chemistry in lithium ion batteries we are going to see in further slides. So first of all, I'll give you the introduction to the lithium ion battery. The term battery was first used by the Benjamin Franklin in 1749. He was doing the experiment with electricity using a set of linked Leyden jar capacitors. We can see these are the Leyden jar capacitor. Here there was a metal link, and here the static electricity was uh, going to the jar, and the electrons were getting stored here. The Franklin grouped several of the jars into what he described as battery, using the military terms for the weapons functioning together. By multiplying the number of holding vessels, a stronger charge could be stored and more power would be available on discharge. So what he did later, he arranged the number of jars in group. So it was nothing but called as battery. As he connected the number of jars into the group, the charge was strong, the charge was more powerful as compared to the single jar. The first electrochemical battery voltaic pile built and described by an Italian physicist Alessandro Volta in 1800. This was the stack of copper and zinc plates separated by the brine-soaked paper disc that could produce the steady amount of current for a considerable length of time. So we can see this was the stack of the copper and zinc plates here. They were separated by brain soak paper. So it was the initial foundation of the batteries what we are using nowadays. So here was copper as a copper and zinc plates as the anode and cathode and separator as the brine soak paper. From here we were collecting the electrons and we were transferring this electron to these terminals. You can see these terminals. From these terminals we were connecting. These terminals were being connected to the load, and we can drive our load with the help of that electrons. Later on, the Daniell cell was invented in 1836 by British chemist John Frederick Daniell. The Daniell cell was named after him only. John Frederick Daniell was the first practical source of electricity, becoming an industry standard. At that time, there was no constant supply of electricity. There were no as good as transmission we are having nowadays. That was the first practical source of battery, or the first practical source of electricity with the help of battery. So what they were doing, they were storing the batteries like they were huge. They were not small as we are seeing nowadays. They were huge battery packs that was stored for the industries, so that when the power cutoff is there, or when the power is not available, so they were taking that electricity from that batteries. So now we will see what is cell and battery. A cell is an electrochemical unit that converts chemical energy contained within its active material directly into the electric energy by the means of electrochemical oxidation reduction, which is known as redox reaction. So see, what is cell? Cell is nothing but it's an electrochemical device which converts chemical energy into the electrical energy from its active material. So there are some active material inside the cell or battery, like copper, lithium ions, manganese, right, alkalis. So these active materials will give one electron, right? And when they are giving electron, we will apply the wires to it so that the electricity could flow from anode to cathode or cathode to anode, vice versa, right? So we are completing the terminals, we are completing the connection, we are completing the circuit. So with the help of this circuit, with the help of this active materials, we are getting electricity so that we can provide it to our circuit. So how do we get this electricity? With the help of redox reaction. So there are some active chemicals inside the battery, inside the cell, which will give us the electrons when the redox reaction takes place inside them. This type of reaction involves the transfer of electron from one material to another via an electric circuit. When two or more electrochemical cells are combined either in series or parallel, such combination is known as battery. So whenever we are combining two electrochemical cells either in series or parallel, it is known as battery. So can anyone tell me what is series and parallel combination? Yes, anyone from audience? Hello. Hello. Yes, can anyone tell me what is series and parallel combination?
The series concept, the two different terminals are connected. When current is positive and negative is joined.
Okay. So in series, we connect positive to negative or negative to positive, and in parallel, we connect positive to positive, negative to negative, right? So we can see this is the basic cell. Here we are having ions, cations. electrolyte solution, anode, cathode, and here we are getting battery, right? So when we are applying battery, so we can see this oxidation and reduction takes place, right? So inside the cell, this two reaction takes place. One is known as oxidation and another is reduction. According to the classical or earlier concept, oxidation is process which involves the addition of oxygen of any electronegative element or the removal of hydrogen, any electropositive ring. So this is an chemicalized theory where the oxidation is known as the addition of oxygen and removal of hydrogen. But we are talking about electrons. So in electronic concept, the oxidation is defined as the process where an atom or ion loses its one or more electron. Means oxidation takes place when any material will lose its electron, and reduction will take place when any material will gain the electron, right? According to the electronic concept, reduction is defined as the process in which atom or ion gains one or more electron. Means when the atom will gain the electron, it will be known as reduction, and when atom will lose the electron, it will known as reduction. So as we can see here, we are having A and B, two materials here. When the atom is gaining the electron, it is called as when the atom is losing the electron, it is called as oxidation, and when the atom is gaining the electron, it is known as reduction. So we can see here, these are the main components of dry cell. Here the outermost covering is of steel can, as we can see here, right? At the upper side, at the positive side, there is steel plated positive cover, where at the outer side we are having PVC label, polyvinyl chloride label. At the anode we are having powdered zinc, and at the cathode we are having manganese. We are having manganese dioxide, carbon, and electrolyte. In here we are having the current collector where all the charges will be connected, so that we can supply those charges through the conductor and we can drive our load. There is seal which will help the battery or the outer part to be insulated. Inner cell cover will be made up of steel plate. Here we can see at the downside here it is negative cover. Again, this metal sulfur and metal washer. So we are having all these components. These are the main components, and the one of the most main component is here the separator. Separator is nothing but it acts like an semi-permeable device. It is an barrier between the anode and cathode. See, we can see anode is a positive charge collector inside a battery. It will release the electrons through the external circuit and oxidation will take place there. So these are some properties of anode which sustains inside the anode. Efficient reducing agent. The anode should be efficient reducing agent. The high coulombic output should be there. The anode should be good conductive. It should be made up of good conductive material. It should be stable. The ease of fabrication and low cost. The main point here is the low cost. If we'll use some rare earth minerals, the cost will go high, and we can't use it for the different type of purposes. All right. So these are some important points. The metals such as zinc, lithium are often used as the anode material, right? The cathode is the negative charge charge collector inside a battery or a cell. It will accept the E from the electron. It will accept the electron from the external circuit. The reduction will take place here. What are the properties of cathode? Cathode should be efficient oxidizing agent. It should be stable when in contact with the electrolyte. The useful working voltage should be there. The ease of fabrication should be there. Low cost. Again, the metal oxides are used for the cathode material, right? As we can see here, At the anode, it's positive, and at the negative, it's the cathode. Here, the oxidation and reduction is taking place, and electron is here in the between. So we will see what is electrolyte. Electrolyte is a chemical medium that allows the flow of electrical charge between the cathode and anode. So what is electrolyte? There are different types of electrolyte: strong electrolyte, weak electrolyte, and non-electrolytes. So strong electrolytes are fully dissociated with water. For example, sodium hydroxide, sodium chlorides, and hydrochloric acid. Weak electrolytes are incompletely dissociated in water, like water, acetic acid, and ammonia, and non-dissociated in water like sugar, alcohol, or oil. So these things depends. So here the electrolyte should have strong ionic conductivity and no electric conductivity. Means from the electrolyte only the ions should pass, no electrons. We need a material such as salts, acids, alkalis, from which electricity will not get passed, only the ions will get passed. It should be the property of electrolyte. It should be non-reactive with the electrode material. We will be using this electrolyte with the electrode materials with anodes and cathodes, so they shouldn't be reactive. Right? The properties: resistance to temperature fluctuation. So electrolytes should withstand the fluctuations in temperature. It should be safe in handling, and obviously it should be lower in the cost. So we will see what is the separator. The main function of the separator is to keep the two electrodes apart from the prevent the electrical short circuit, while also allowing the transport of ionic charges carrier that are needed to be close the circuit during the passage of current in the electrochemical cell. So we can see here, this is separator. This separator is made in such a way, it acts as a semi-permeable device. It acts as a barrier for the electrons, and it acts as a conductor for the lithium ions. So here we can see these electrons are passing from the outer circuit, and these lithium ions are passing through the inner circuit. So this is main important function of the separator, to keep the electrodes apart to prevent the electrical short circuit. So what happens if the separator will get disturbed or if it gets damaged? So all the electrons will travel from inside only. So it will get short circuit. What is electrode? Electrode is an electrical conductor that makes contact with the non-metallic circuit parts such as electrolytes, semiconductors, or vacuum. If an electrochemical cell, this is also known as cathode and anode. Electrode is nothing but we are having that non-metallic circuit parts inside the cell. So we need to connect some conductive or some metallic parts with that non-metallic parts, so that we can get electricity from that outer surface. So it is nothing but anode and cathode. So how the working of cell takes place, we can see here. This is the electrolyte solution. This is anode, this is cathode. So, and this is semi-permeable barrier, means separator. So this anode, and the electron is flowing from anode to cathode. When the electron will be flowing from anode to cathode, this lithium ions will be flowing from anode to cathode from the internal circuit, and we will apply the load here at the external circuit. So what happens at discharging? We can see at discharging, this lithium ions are passing from the anode to cathode, and the electrons are moving from anode to cathode from the external circuit. This is electrolyte solution. The anode is negative charge here, and the cathode is positively charged. Positive ions are moving from anode to cathode, as I have told you, and lithium ions are moving from cathode to anode. The external circuit E moves from, the electrons are moving from anode to cathode, right? What's happening when charging? At charging, the positive electrode is anode and the negative electrode is cathode, right? At the internal circuit, positive ions are moving from cathode to anode, positive ions are moving from cathode to anode, and the negative ions moving from anode to cathode. And here the electrons are also moving from cathode to anode. So we can see the direction of the electrical flow, the direction of charges, right? So in this way, the charging and discharging takes place here. So we are going to see the different types of batteries which we use nowadays. Moving on to the battery type, there are two main types of the batteries based on the nature of cell. Batteries can be classified into primary and secondary batteries. A primary is one non-rechargeable battery and secondary is rechargeable batteries. So what are the types of battery? First of all, primary cell, secondary cell, reserved cell, and fuel cell. So there are different types of classification inside the battery. Primary cells are having alkaline batteries and coil cell batteries. Secondary battery, we can see the lead acid battery, nickel cadmium battery, nickel metal hydride battery, lithium ion battery, and lithium ion polymer battery. So what is primary cell? Primary cell is nothing but a cell which is not rechargeable. Primary cell or batteries are not rechargeable and cannot be reused. It's electrolyte or when it's all consumed, right? When these batteries get discharged, they serve no purpose and must be disposed. Some common examples of primary cells are ones we use in remotes, wall clocks, watches, and many electronic gadgets. So see, what is primary battery? Primary battery is nothing but a non-rechargeable battery which we can't use again and again. So this battery serve no purpose, that are of no use when we get it discharged. So these are mostly used in remotes, wall clocks, watches, toys, electronic gadgets, right? Again in this, there are two types, mainly alkaline batteries. The chemical composition of zinc and manganese dioxide from these batteries, the electrolyte that is used in this type of batteries is potassium hydroxide, and since the content are purely alkaline, it is termed as alkaline batteries. So here we are using the chemical composition of zinc and manganese dioxide. So as we are using here potassium hydroxide, so here we are using all the alkaline material, all the alkaline chemical, thus it is called as alkaline batteries. Secondary cell, what is secondary cell? Secondary cell is nothing but the cell which can get recharged. We can use them again and again. They are multi-purpose cells, right? The secondary cell or a battery is the one that is rechargeable and serves multiple purposes for a longer span. Passing current opposite to the direction of discharge, one can effectively recharge the cell again to its original state. Common examples of secondary cells are the one we are using in the cars, UPS, robotics, cordless mobile phones, solar lights, and drones. We can see these are the some secondary cells which we can use multiple times. We can use them for the longer period of time. We can recharge them. We don't have to throw them out when they get discharged. So these batteries we are mostly using in cars, UPS, robotics, mobile phones, right? Smart watches. Hello. Am I audible to all?
Yes, you are audible.
So as we can see, in the secondary cells, we are having different chemicalized cells like lead acid battery. The lead acid battery is the oldest rechargeable battery system. The lead acid is rugged, forgiving if abused, and it's economically priced. But it has high dose it has a low specific energy and limited cycle count. See, this lead acid battery is the oldest rechargeable battery we have ever discovered, we have ever invented, and we are using it from the longer period of time. So lead acid battery is very rugged, uh, very very strong, and it is strong enough so that even if there is some electrical abuse or any kind of physical abuse to the lead acid battery, it can withstand it, right? So even if we are charging it for the longer period of time, or even we are discharging it the high current rates, or even the temperature gets higher, then also the lead acid battery can withstand them safely. Though it will affect up to the some certain percent of its battery life, but not as much as the lithium ion. So the lead acid battery is very rough and tough battery which we are using nowadays. Though it is having some disadvantages, like it has having low specific energy capacity and it is having limited cycle count. Though the lead acid battery is used for the wheelchairs, golf cars, personal carriers, emergency lightings, and uninterruptible power supplies (UPS). The another disadvantage of battery is it contains the lead, which is toxic and highly harmful to the environment for the human beings as well. So thus it cannot be disposed into the landfills. They need the proper disposing. Another is the lithium-ion batteries, which are made up of lithium metals. They are compact and can easily be used in portable device. All right. So this is the one advantage of lithium-ion battery. It is portable and it is compact. But the disadvantage of lead acid battery, it's not so portable, it's not so compact. The weight of the lithium ion battery is very less as compared to the lead acid battery. So these are the base batteries in secondary characterization, which is having the nominal voltage of 33.7 volt, right? And the power density of 126 watt-hour per kg. The lithium ion is replacing the many applications that were previously served by the lead and nickel based batteries. Nowadays, we are using lithium ion batteries mostly due to its safety concerns. The lithium ion needs the protection circuit. It is more expensive than most of the other batteries, but higher cycle count and the lower maintenance reduces the cost per cycle over the many other chemistries. Though the lithium ion disadvantages, it's having some safety concern. We need the extra protection circuit, which is known as BMS, to keep this lithium ion battery safe, to keep this lithium ion battery within its limit. But though the price is high and there is some safety concerns, but it's lower maintenance and over the cycle count as compared to other chemistry, it's still beneficial. A lithium-ion battery or LIB is the type of rechargeable battery that is used in lithium-ion as the main charge carriers. It is a popular choice for the wide range of applications, including the smartphones, laptops, electric vehicles, power tools, and energy storage systems. LiPo. These batteries are also known as lithium-ion polymer batteries, as they are using polymer gel or electrolyte instead of the liquid ones. These batteries are a bit costlier, but are highly protected as compared to lithium-ion batteries. They are having power density of 185 watt-hour per kg. So as the lithium-ion battery are the type of rechargeable batteries, and we are having here the lithium ions as a main charge carriers. So here we are using this in electric vehicle, right? So lithium ion batteries are mostly used in electric vehicles, again in the smartphones, laptops, some power tools, and energy storage system. Lithium lithium ion polymer battery, what is lithium? Here we are having the polymer or electrolyte as instead of liquid ones. So here, due to that polymer gel and electrolyte, the cost is bit high, but it is having good protection, right? And again, it is having good power density. Yes, is there any question? Hello.
No, sir.
Okay. So, advantages of lithium-ion batteries. So, what are the advantages of lithium-ion batteries here? It's high energy density, right? So, in lithium-ion batteries, we are getting high energy density as compared to the lead-acid battery. Lead-acid battery is having lower energy density. Though the weight of lead-acid battery, can anyone tell me where we are using the lead-acid battery nowadays? Hello. Hello. Yes, can anyone tell me where we are using the lead acid batteries?
IC engine vehicles.
Right, IC engine vehicles. Apart from IC engine vehicles,
Mobile phones.
no, we are not using lead acid batteries into the Yes, anyone other? At our homes, where we are
Inverters, sir. Inverters.
yeah, right, exactly. Inverters. So have you seen how heavy that battery is? How heavy that inverter battery is? Have anyone tried to pick up that battery, or have anyone tried to shift that battery?
Yes, sir. It's very heavy.
Yeah, it's very heavy. So again, as compared to the lithium-ion batteries, it's very heavy. The same energy density of the lithium-ion battery, and if we will take the lithium-ion battery of same energy density as the lead-acid battery, the weight difference will be so much, like near about 40 to 50%, right? So the same amount of energy density into the lead-acid battery will be 40% greater. The weight of the that lead acid battery will be 40 to 50% greater as compared to the lithium ion battery. So the high energy densities lithium ion will provide us more energy storage capacity for their size and weight as compared to the other battery types. Again, they are rechargeable. Lithium ion batteries are rechargeable, allowing them to be reused multiple times and making them cost effective in long run. So as they are rechargeable, so we don't have to throw that battery away if it gets discharged, as we are doing in our remotes or in the toys. What we are doing, when the cell gets discharged completely, we are throwing that cell and we are getting the another one. But as the lithium ion batteries are very costly, but though they are cost effective, as we can use them for the long run. The initial cost of the lithium ion battery is greater, but in the long term, they are very beneficial. Again, the lithium ion batteries are having slow self-discharge rate. So can anyone tell me what is self-discharge rate? What is self-discharge? Can anyone tell me what is self-discharge?
The battery is discharged without connecting.
Battery gets discharged due to its
internal resistance.
Internal resistance, right? Exactly. So even when we are using some bikes or cars, if we are not using that bike or car for like 1 month or 2 months, it just park, right? So it won't get started, right? We need to push it or we need to recharge that battery. So what's happening to that battery? It's getting self-discharged due to its internal resistance. So though the lithium-ion batteries are thus the lithium-ion batteries are having lower self-discharge rate as compared to the other batteries, so we can use that lithium-ion batteries for the longer period of time. So our electricity, our charge won't get wasted. Again, the lithium-ion batteries are light in the weight. They are relatively lightweight, making them suitable for the portable device and electric vehicle. Though the electric vehicles, some past electric vehicles, retro electric vehicles use lithium lead acid batteries, but they were not so efficient. So that's why we are now moving towards the lithium-ion battery. So the lithium-ion batteries are lightweight, so they are mostly used in portable device like electric vehicles. Again, in your laptop we are having the lithium-ion batteries. Again, in the mobile phones we are having the lithium-ion batteries. Bluetooth devices, earphones, earbuds, we are having the lithium-ion batteries, right? Fast charging. Again, the many lithium-ion batteries support fast charging, enables quick recharging times for device and electric vehicles, right? Here we are getting again one more advantage of the lithium-ion batteries as compared to the lead-acid battery. The lead-acid battery takes 8 to 9 hours to get fully charged, right? More than that sometimes. But lithium-ion batteries are getting quickly charged nowadays. We are having some fast charging technologies. We are having some high current giving capacitors technology, which can charge the lithium-ion batteries very quickly. So that's all by my side. The audience is open to ask the questions. Hello.
So what are the common issues in lithium-ion battery?
Sorry.
What are the common issues?
The common issues in the lithium-ion batteries, they are unstable. They are highly insensitive to the temperature variations. So to manage these temperature variations, we are implementing the battery thermal management system inside the electric vehicles. Again, the lithium-ion batteries are intolerant to the voltage and current variations. We can't we need to be very careful while charging and discharging the lithium-ion battery. So
Heating are the main common issues, right, sir?
yeah, heating and overcharging.
Yeah, thank you.
These are the main two common issues: heating and overcharging.
Hello.
Yes.
How the overcharging can be controlled?
Yeah, how the overcharging can be controlled. So here we are installing the another device which is known as battery management system. This battery management system will control the overcharging, over discharging, temperatures, over voltage, under voltage cutoffs of the lithium-ion batteries.
Okay. The range is fixed about that overcharging, the voltage and etc.
Yeah. Whenever the lithium-ion batteries are getting manufactured, right?
Okay.
So the manufacturer will give us some instructions that batteries should get like this much voltage should be given. Some standards will be given by the manufacturer.
Okay. So that device is made according to the requirement of different.
Right.
Means for car it might be different, for other if it is going to be used in e-rickshaw and other, then device should be made different, I suppose.
Yeah.
Okay, that's good. Okay, thank you very much for very nice.
Sir, how to know which type of BMS should be used?
See, whenever we are getting lithium-ion batteries, so there are different types of chemistry inside the lithium-ion batteries, like lithium-ion phosphate, NMC, LFP, right? So we need to get that BMS according to that chemistry. We can't use the NMC BMS to the lithium-ion phosphate, or we can't use the LFPs to the NMC battery, right? So we need to see that accordingly. We need to see that.
If anyone having doubt, please ask from the expert.
Yes, any other questions from the audience?
Thanks for hosting the webinar. Your expertise and insight were invaluable for our learners. I would like to take the opportunity to introduce our company ISI India product and services that we offer in EV technology with a small video. So kindly have a look on video.
As we are living in the fast-changing world of electric vehicles, ISI India is leading a tech organization, paving the way for innovation and devotionalizing the ecosystem. It is bridging the gap between industry and academia and bringing all the stakeholders to the same table. From 2013, our parent organization has been tirelessly working to create an ecosystem for skill development, research, innovation, and entrepreneurship in the electric vehicle industry. Through CSR skill development and partnership with GIZ, Tata Technologies, Bharat Crop Science, Kalika Industries, Chalna Jan Seva, Masiya, IPCA Laboratories, etc. And with national and international e-mobility events such as Electric Solar Vehicle Championship, Formula Imperial, Indian Karting Race, E-Bike Design Challenge, we have provided a platform for over 3 lakh students from more than 750 colleges and universities to come up with innovative projects. In addition to this, we are offering various skill development programs, faculty development programs, corporate trainings, and spectrum of courses with duration from 9 to 12 months with live and recorded interactive classes, with the added flexibility of paying after course completion. For our contribution towards building sustainable way forward in EV, we have got recognitions such as the National Youth Award from Ministry of Youth Affairs, Government of India, Titans of Technology Award, EDN Star Award from Earth Network USA, and the Social Entrepreneurship Award. And we have also joined hands with Automotive Skill Development Council, All India Council for Technical Education, National Skill Development Corporation, Ministry of New and Renewable Energy, and various automotive industries, which validate our global impact and commitment towards excellence. We are now a global partner for talent nurturing in the automotive industry. We are fostering the youths for the global EV market and have recently joined forces with partners in Malaysia, Indonesia, and South Africa. According to the economic survey, in India, the market for electric vehicle is expected to grow really fast, about 49% every year from 2022 to 2030. This means we could see 10 million electric vehicles sold every year, in which led to 50 million direct and indirect jobs by 2030. We are committed to sustainable mobility solutions, and our industry-aligned programs cater academia, industry, and government sectors. Our expertise in the industry has led us to design cutting-edge technological solutions for the growing electric vehicle industry. We promote project-based learning, hands-on training, skill development initiatives, vocational training, research, entrepreneurship, public-private partnerships, awareness and outreach programs. Our state-of-the-art facility, the Center of Excellence for Electric Vehicle, is dedicated to spreading the word about electric vehicles by facilitation of technological advanced solutions. EV Tech Lab. It's a high-tech lab designed for students studying engineering, ITI, and polytechnic students getting job training. Think of it as a space where creativity meets actual hardware solutions. People here get to dive deep into the physical part that make electric vehicle work. This model is also helping our partners for community skilling of various job roles, such as electric vehicle technician, vehicle assembly operator, charging station operator and technician, and workforce for electric vehicle powertrain, battery and BMS maintenance, etc. Second model, that is our Center of Excellence for Electric Vehicle. It's a combination of labs and offering both hardware and software solutions, under which we have established end-to-end solutions for electric and hybrid vehicle design, powertrain, battery and BMS, EV charging, IoT for experimental learning, testing and prototyping. The solution we are providing is unique and help our learners for upskilling, research by getting experimental data and plotting graphs. Our goal is to impart industrial knowledge by establishing pioneering center of excellence. These centers, developed in collaboration with universities, industry partners, and government entities. Our COEs provide integration of EV curriculum in BTech, MTech, and other academia programs. Research and vocational NSQF courses aligned with the national education policy. Plus, our COEs also support the startup ecosystem by providing facilities for design, prototyping, and product testing. Our labs are making difference. We have established several labs across strategic locations with all kind of stakeholders like industry, Hero MotoCorp, with Government of Kerala in partnership with MG Motors at 2 locations, IIT Mandi, private universities like SNMU, Calcutta University, Sharda University, an NGO with Govardhaniko Village by ISKCON Temple, and various top universities and institutes across India. Our commitment to excellence is unwavering, and by 2025, we aim to establish over 250 plus centers of excellence worldwide. With India rapidly moving toward an electric-only future, ISA India is well positioned to develop the workforce prepared for the international arena. Join us on this electrifying journey towards a sustainable and innovative future.
Thanks for watching the video patiently. So don't miss out on this opportunity to discover the endless possibilities of EV. So any of you want to enroll in this course, kindly send us inquiry through a QR code displayed on your screen and take your first step towards a more sustainable and exciting future. Thank you.
Sir, not audible.
If you have any queries regarding any course, you can scan this QR code. Our executive will contact you shortly. Thank you for attending the webinar. Hope if you have any query regarding the courses about battery, BMS, you can scan this QR code and our executive will contact you shortly about the courses. Also, don't forget to fill the feedback form which is given in the chat box, and certificate will be shared after 48 hours due to maintenance of our website.